Hello students. So we saw relation, equivalence relation and conditions, that is it has to be reflexive, symmetric and transitive. Okay, I have defined all three conditions. So let's take one example, okay, where we'll be understanding more in depth about reflexive, symmetric and transitive. Okay, so I'm taking one set A 1 2 3 and I'm writing one relation. Okay, so if we have 1 comma 1 2 comma 2 3 comma 3 1 comma 2 2 comma 1 3 comma 1. Okay, so I will remove this. Okay. So let's check reflexive. So what does the definition says? A relation is reflexive if A comma A belongs to R for all A belonging to A. So you have to check for every A belonging to A. So here the elements in A are 1, 2 and 3. So 1 comma 1, 2 comma 2 and 3 comma 3 should belong to R, and they are present in R. So we can say that it is reflexive. So you have to look for the elements in A, every element of A. Okay. Then second property, second condition is for symmetric. Symmetric. Okay. Here if A comma B, any one element from R we are taking, then B comma A belongs to R. That is, its symmetric element belongs to R for all A and B belonging to R. Okay, belonging to A, sorry. So now you have to look out for every element of R and its symmetric element. Now 1 comma 1, its symmetric element will be 1 comma 1. Okay, it is present in R. Also for 2 comma 2, also for 3 comma 3. Now I am taking 1 comma 2 belonging to R. So we have a element 2 comma 1 belonging to R, which is a symmetric element of 1 comma 2. So this says that this relation is symmetric. Okay, suppose we had one more element here. Suppose I am taking 3 comma 1. Okay, now you have to check for the symmetric element of 3 comma 1. 3 comma 1 belongs to R, but 1 comma 3 does not belongs to R. So this one element makes this relation R not symmetric. Okay, now let's just check for transitive. I hope you understood this. That is, you have to check for every element of R. You have to take and see if its symmetric element belongs to R or not. Okay, let's check transitive. Okay, so if there is a element A comma B belonging to R, okay, and B comma C belonging to R, okay, then if we get A comma C belonging to R, then we can say that this relation is transitive. Okay, so let's check for every element of R. Now I have 1 comma 1 belonging to R. So you have to take element which starts with 1. Okay, because here B is your 1. So we need element which has starting number 1, and then we can take any other number. So 2. There is 1 comma 2. 1 comma 1 and 1 comma 2. So 1 comma 2. AC is 1 comma 2 and this belongs to R. Okay, so we got transitive property proved for this element 1 comma 1 and 1 comma 2. Now take 2 comma 2. Now search for element having first number 2. So 2 comma 1 is there. And the transitive element will be 2 comma 1. So it is present in R. Okay. Now take 3 comma 3. We have 3 comma 1 present here. Okay, so this is 3 comma 1. So it is present in R. Then look for 1 comma 2. So we need 2 comma 1. It is also there. Then this gives you 1 comma 1. So it is present in R. Then you can take 2 comma 1. So it's another element starts with 1 comma 2. So you'll get 1 comma 1 or 2 comma 1 and 1 comma 1. So again you will get 2 comma 1. It is present in R. Now let's check for 3 comma 1. 3 comma 1 and you can take 1 comma 1. So 3 comma 1 is present in R. Then there is one more element 3 comma 1 and 1 comma 2. Okay. 3 comma 1 belongs to R and 1 comma 2 belongs to R. Now see here 3 comma 2 is not present. So this is not transitive. This relation is not transitive. Okay. And one more thing I want to add, that is if you have a relation set, say 1 comma 2 and 3 comma 1. Okay. Now if I choose this as A comma B, okay, so there is no element in the form B comma C, correct? So we can directly say that this relation is transitive, okay, because there is no element B comma C, so there will be no element A comma C. So you can directly write this relation as transitive. Now check for this element. This element is also of the form A comma B, so there is no here it is possible, because see, this is 3 comma 1 belongs to R and there is an element with 1 comma 2, okay, belonging to R, but 3 comma 2 is not present in R. So we can say that this is not transitive. Okay. So if it was only one element here, then we can say this is transitive. Or we had elements like three comma 4. Now these two elements are totally different, right? This, if we take A comma B, this is not B comma C. Okay, so we can directly write this as transitive. This relation is transitive. Okay, I hope you have understood. There is a question in exercise. Okay, so if you solve that, then you will understand the concept of transitive, reflexive and symmetric.